So this is our compact micro drive. So I'm going to start with just a VFD lineup. And actually before that, we'll show you just kind of where we are at on the timeline, historically speaking. So I think we've, made a better name for ourselves. People are more familiar with LS Electric now more than they were a few years ago. And this just shows that we've been making VFDs for a while. Since the 80s, we started working with Fuji. We started our own design, came out with the Startvert series. We went to the IS5, then IS7, and then now pretty much everything is on the 100 series. So there's the S100, the H100 and H100 Plus, the M100, the G100. What we're going to be talking about is the G100. This is just showing a more in-depth list of other drives. Most commonly what we'll see as far as older drives are the 5 series, the IP5A, which is a pumping drive, and then the IG5A, which actually the G100 replaces the IG5A. So if you think G to G, that's what the G100 was released for, to replace that older product. So this is just a little circular diagram of what we offer. So our most basic simple drive is the M100. Also, one of the limitations with the M100 is it's a single phase input only. So single phase 230, single phase 115, 3-phase out. So we only run 3-phase out drives, 3-phase motors. A step up from the M100 would be the G100, which is our main focus today. That's a 3-phase in, 3-phase out drive. We could also derate it on the front end, double the horsepower to get a single phase in, 3-phase out. The S100 is kind of a step up from the G100. So if you ever have an application that requires safe torque off or torque limits or a specific communications protocol, you might need to step up to the S100 over the G100. Another unique thing about the S100 is we have the NEMA 4X variant up to 30 horsepower. So that's pretty much an S100 in a 4X box, so washdown rated IP66. And then we have the IS7, which is our top of the line flagship industrial drive. And then we also have the H100 Plus drive, which replaced the H100 drive. So it's a massive firmware update. That's a whole nother topic. So focusing on the G100, again, this is our micro drive. So we go up to 10 horsepower. So this is a general purpose kind of industrial drive. You could also apply it for fans and pumps, but out of the box, it's heavy duty rated. So we could do up to 10 horsepower heavy duty, constant torque. You could flip a parameter and then you'll get 15 horsepower variable torque out of it. So some of the nice features built into this, and we're going to be diving into these more. Maybe we'll be mentioning them a couple times just to kind of reinforce it. Built-in speed potentiometer, DIN rail mount. So that was something that people requested for a while when we had the just the S100. Now it's built in, DIN rail mount up to 5 horse. We have the flying start, which is catching a motor on a fly, as well as power loss ride through. We have an external brake control with the relays. It's a C3 EMC filter, so electromagnetic filter, built into the 480 volt drives. And then I mentioned the 2 overloads, the dual rating. So we have a 120% overload, variable torque, normal duty, and then 150% heavy duty, constant torque. 2 different voltage classes, 200 volt and then 400 volt. So the 200 volt class is good for 200 to 240 volt. And then the 400 volt is 480 down to 380 volts, plus 10%, minus 15%. Most of the time, I think people are going to be using V by F control method. So that's just like a straight, V by F pattern. We also have a slip compensation mode and a sensorless vector mode if you need, to maximize the amount of torque that the drive's going to output to the motor. All of these drives, just like all of our drives, no matter what series you're looking at, are going to be standard IP20, and then we have a optional conduit kit that gives you the NEMA 1 rating. So if you're going to put this on a wall in a mechanical room, you're going to want that conduit kit. So that's an accessory, field installed accessory. This meets the new UL 61800-5-1. So that actually replaces the UL 508C. We also have global conformances, so CE, UL, CUL, and then the RoHS compliance. Also, all the boards, I think we have another slide on this, are 3C2 conformal coated. So that's included. It's not like an option or anything. It's just conformal coating on all the boards. So help with some nasty environments perhaps. And then we also have the built-in Modbus RTU, which is standard. So yeah, so we additionally, I'd say most commonly, we have the dual port Ethernet IP card. And then Can Open and Profibus, those are on the price sheet, but I don't think we stock them yet. We might have maybe one or two, but most of the time people are going to be using Modbus RTU, or we have the dual port Ethernet IP card, which could actually do Modbus TCP as well. Next thing we're kind of focusing on here is just like drive selection process. So this is a question we get every day is we'll get emails or calls and say, hey, I need drive for 5 horsepower motor. Okay, well, what's the FLA? The drive is a current rated device, so we want to know the amperage so we can properly match the drive. And then more important than that is the supply voltage. You know, most of these motors are going to be dual wound. So are you running 230? You're running 460. What about your input? Is it 230, 240, 208, 480? Also, are you running single phase input or 3-phase input? So I mentioned the G100 is a 3-phase drive, but we could actually derate it and oversize it to run a single phase input. So we have tables for that as well. Application is also important. Is it heavy duty or normal duty? Is it constant torque or variable torque? So to kind of simplify that, you know, there's a million applications. Variable torque applications and normal duty is commonly associated with fans and pumps. So most pumps, most fans are going to be variable torque. So that means the amount of torque required changes with the speed. When you're at full speed, that's when you need the most torque. Whereas if you think about like a rock crusher, a conveyor, a winder, or anything like that, no matter what speed you're at, you need to output the same amount of torque. That is a constant torque application, which is commonly associated with heavy duty. So we'll always ask about the application so we could pick out the best drive for you. Installation environment is important. If you're going to be installing the drive in a high ambient temperature, you got to watch the specs. Same thing for high altitude. So we live in Chicago here, so we don't have to worry about it, but we work with people in Colorado and such, or somewhere in South America where there's high altitude. Then we have to derate the drive again for that situation. Enclosure and NEMA ratings. So all the drives are IP20, so that means they're finger safe, but they have like a little wire guard on it. It's not NEMA 1 rated. So you'd have to buy a conduit kit if you want to make it NEMA 1 rated. If you get into an application where you need a washdown drive, so you could spray it with a hose, well then the G100 is not going to work for you. You're going to need to go to like an S100 4X, or you're going to have to put a drive in a box that's rated for it. Serial communications, I think that was the last thing we just mentioned on the previous slide. Do you need Modbus RTU? Do you need Ethernet IP? Do you need Profinet? Do you need nothing at all? That affects what drive you go with. So for example, if somebody says they need BACnet for a HVAC application, we go H100 Plus because that drive has the BACnet built in. Encoder feedback, this one we don't run into too often, but if you ever run into an application that says I need encoder feedback connected to the drive, so that's like a tachometer on the back of the motor that goes to the drive, that needs to be the IS7. Currently the IS7 is our only drive that has the encoder option capability. So those are the questions you got to answer. This is like just a little table that shows kind of where the G100 lands across you know, the spectrum of different applications. So smaller fans, smaller pumps, just basic things like that, the G100 would be perfect. So as long as it's 15 horsepower or less, the G100 is going to be a very competitive offering. Those are considered lower performance. They don't need a ton of features. If you run into stuff like, you know, winders or web applications and wireline and things where you're doing torque control, that's when you're probably going to switch to the S100 or the IS7. And then the same thing with capacity. If you're going up to 20 horsepower, up to 800 horsepower on a fan or a pump, we're going to switch you over to an H100 Plus because that drive goes up to 800 horsepower, whereas the G100 only goes up to 15 horsepower normal duty. All right, so now we're going to get into some of the features for the G100, and some of these actually transfer over to our other drives, like this one here. So I don't think anybody scans these QR codes because it's kind of subtle, but on all of the LS drives, there's a little QR code on the cover, and we're circling it on the bottom of the screen here. And if you scan that with your phone's camera, it's going to take you to this QR website. And I actually have this bookmarked on my phone, and I use it if I ever get like an after hours call. This has wiring, parameters, specifications. It has the full manual that you could search and everything, all on your phone. So as long as you have access to the internet and you scan this QR code, you should have enough information to do a startup. It actually has the quick start guides on here too, which I have some screenshots of some quick start guides as well. So just keep that in mind. If you're ever helping somebody with a startup or doing a startup on your own, you could scan that QR code and it'll try to guide you in the right direction. The G100 has 4 different frame sizes. So we have frame 1, 2, 3, 4, and you can see it's kind of like a shared frame. So like a 0.5 horsepower and a 1 horsepower is going to be frame 1, and then the 2 and 3 horsepower are frame 2, and then so on. And the 7.5 kilowatt is the biggest frame we have, so that's 10 horsepower. Again, 10 horsepower heavy duty, that's what the drive defaults to. So all of these specs as far as dimensions, we should have the CAD data on our website, and then we also have it in a PDF format in the catalog as well. As far as the model number, so the model number follows suit with all the LS VFD model numbers. So we always start out with an LSLV, which is an LS low voltage product. Then you have a 0008. Everybody loves this because we have the drive set up in kilowatts, but we're in the US, so we don't like kilowatts, we like horsepower. So there's actually an implied decimal place. So 0.8 kilowatts would be 1 horsepower. So 1 horsepower is 0.75 kilowatts about. So you could either look in our quick start guide, we give you a conversion table for picking out the horsepower, or you could remember the formula or Google it or whatever. Then we're going to have the series name, so you'll have G100, and then most importantly, you have your voltage class, -2, -4. So I'll show you a screenshot of the quick start guide. One of the first things you do when you get a drive is make sure you have the right voltage class. If you ordered a 480, but you grabbed a 230 volt and apply 480 volts to it, it's not going to be a good time. So you always want to verify your incoming voltage matches the supply. These last 4 digits here, it kind of looks like there's options, but really there is no options. You're always going to have an LED keypad. It always comes as an open type, so that means if you want to make it a closed drive, you got to buy a conduit kit, separate option card. And then the EMC filter is going to be standard on 480 volts. So EMC filter is just a filter that shunts the noise the drive creates to ground. And then lastly, you have a reactor. These drives are smaller, so I think they're all N-type, so they have no reactor built in. If we were talking about like an H100 Plus, for example, when you hit 40 or 50 horsepower, then there's a reactor built in. So that's a DC link choke, but these don't have it. This is just a table that's found in the catalog of the specifications. So if you think back to maybe 5 slides ago, we were talking about how you pick out a drive. This is the table that you're going to be looking at. So if somebody says they have a 230 volt application, you would look at this G100-2, which is a 230 volt drive. You could size the drive based on horsepower, but what we would really like to do is size it based on current. So you can see the 4th row down, there's rated current on the output, and then there's that heavy duty, normal duty. So again, the application is important. And then below that, you can see we have the single phase input rating. So if you're going to be running a 10 horsepower drive with a single phase input, we could get 22 amps or 7.4 amps out of it. So you're going to get about half of the amps that it's rated for as 3-phase. This is the same, but it's 480 volt. So obviously it's going to have different amperages with the higher voltage. All right, so here's just a review of some of the features mechanically speaking. A big plus is DIN rail mount. So you could do DIN rail mount. You could also do side-by-side mount. So if you think micro drive, you want to put as many drives in a package as possible, put them all next to each other. You could put these drives 2 millimeters side by side. So it's virtually touching. There is a different ambient temperature rating you got to look at when you're doing the side-by-side mounting. We do talk about that in like our full class, and it's in the manual and stuff. So you could always reach out to us if you have questions about it. Yeah, you have a captive screw on here, so one screw, and then the whole cover comes off, and then it looks like the picture on the bottom right here. And yeah, this is showing like the ground screw, the EMC screws, and all that. So this is a very small and compact drive. This is the power and control diagram. So on the top, you're going to have your power. RST is your three-phase in. UVW is your three-phase out. And then the bottom section of this schematic here, you have your I/O. On the left is your input. On your right is your output. It looks like they have the relays on there too on the left. But we have 5 inputs, P1 through P5. We have our common. We have 2 relays, 2 analog ins, 1 analog out, and then we have the serial communication port as well. Yeah, so this is just showing the power terminal connections. So with the 4 different frame sizes, it kind of goes from like a double stacked terminal. So those are a little bit trickier to wire up because the drive is very small. But then once you hit the 7.5 horsepower, then it's a straight across terminal block. So it's a little bit easier to wire. You can see that the screw size has changed and recommended wire gauge and all that good stuff. That's what we're showing you right here. This blue terminal strip is the I/O terminals. So we have a 24 volt terminal, which is good for 100 milliamps. So that would be great for maybe some LEDs or a transducer if you're running like a pressure control loop. We have the terminal for your speed pot, VR, V1, and CM. We have the P1 through P5, which is your digital input, start, stop, trip, reset, and then a speed setting, speed step. And then we have the 2 relay outputs, which are good for 1 amp, 250 volts AC. All right. So with the G100, it has a small keypad, but we kind of did our best to try to make it user-friendly. So I always think that, you know, a simple drive like the G100 usually has, you know, simple operation. So with the built-in speed pot, we could set that dial on the screen to be your speed reference. So if somebody just comes up and they turn the dial up and down and their speed changes. So if they don't have a PLC, they don't have a controller or anything like that, they could just manually adjust the speed up and down. So that's a nice feature there. This is on the G100 and it's on the M100 drive I mentioned earlier, but it's not on any of the other drives. This is a unique thing. So speaking of user-friendly, it's a 7-segment display, and I think the next slide shows you how the parameter setup works. We did our best to try to group things together and make it somewhat intuitive and easy for you. Even though the terminals are small, there's a 5mm pitch, so you should be able to fit in a pretty big wire into the I/O terminals. And I think we already mentioned these digital inputs, 5, 2 analog. So we have 1 4 to 20 input, and then we have another one that's a voltage 0 to 10 input. Additionally, we have we're showing you this on the right. There's a little door right there, or window. You could pop that off, and you could plug that into your computer with as long as you have the right cable, or you could actually plug that into a 485 network. It's for Modbus. All right, so here's how the keypad works. So pretty much you have a mode shift key that goes through all your parameter groups. So in tech support, we'll do this all day. Press the mode key. You'll see DR for drive, BA for basic, AD for advanced. It goes through the 10 or 12 parameter groups. Up and down goes through the different codes, code 1, 2, 3, 4, 5. We also have a main operation group, which goes through basic parameters such as XL, decel, things like that, enough to get you going. And if you're running everything off of the keypad, you could program that speed pot, as I mentioned, to be your speed, and then you could set the run and the stop reset key to be your run and stop. So you could run 100% local off of the drive if that's something you want to do. Here's the parameter groups I was just mentioning. So when you hit that mode shift key, you'll see it cycles. This picture is kind of counterclockwise, so it's going to say DR for drive group, BA for basic, AD for advanced, CN for control. Then you got input and output. That little CM, it looks like an M, but it's a wacky M. That's just because it's a 7-segment display. And then it loops around. And if you actually hold the key, the mode shift key, it'll actually go counter or it'll go clockwise. So it changes the order in which it goes through. Whenever you're changing parameters, I don't have a live demo set up here to show you guys, but we do have another video that shows G100 programming. I think it's a short video. You just pretty much highlight what you need to be in, and then you press the enter key, adjust your parameter setting with your up and down arrows, and then you press enter twice. The biggest trick on the G100 and the M100 and these little displays is you got to hit enter twice to save the change. All right, yeah, this is explaining the groups, which I actually just explained, the drive group, the basic group, the advanced group. Typically, most setups, you're just in like the first 2 or 3 groups. You do your 10 parameters, and then you're all good. So we do that all day on the phone. All right, some of the other features that we would encourage people to add in on their basic startups is ETH. So this is electronic thermal motor protection. So you can kind of think of it this way. If you go ahead and you program BA13, that's your motor current. So the drive's going to be looking at the motor current, and it's going to trip out when you go above the amperage. You'd probably want to go a step further and enable the ETH. And what this does is it actually looks at the motor speed and the amperage. So if you set your motor to be a self-cooled motor, so that's like a 2 or a 4 to 1 turn down ratio. So if you go less than what the motor's rated at, the motor can't sufficiently cool itself, so you could burn up the motor and overheat it. But if you enable the ETH and then tell it what kind of motor you're running, the drive's going to protect the motor. So it's just a good way to protect your investment in the motor, keep the application going, and limit any downtime. So we recommend enabling this. This is our quick start guide. So quick start guide just goes through basic startup. So you can see step 1, first thing I mentioned is you always want to make sure the model number matches what you ordered, make sure your voltage class matches your power source, remove the cover, wire up your 3-phase or single-phase in, wire up your motor, then go ahead and start going through your programming. Check direction, check your motor settings and everything like that. So we send this out all day. The good thing is usually when we send it out, we don't get too many questions back. So it should cover pretty much anything that most people run into on a basic startup. So this is the back side. So it is a 6-step process. Step 4 is just navigating through the keypad. Step 5 is basic control wiring. Where do I put my run command? How do I start and stop the drive? What about if I have a speed pod or a 4 to 20 input? This shows how to wire it. And then on the far right, step 6 shows how to program, motor data and extra protective stuff. Okay, so some other things built in, and I mentioned this, I think, on the first or second slide that had the G100 overview, is the control modes. So most of the time, probably 95% of the time, we're running in a V by F control. So V by F is volts over frequency. So you can see that table on the right. As your frequency increases, so does your voltage. So that should make sense. We default to like a linear V by F pattern. So if you're at half speed, that's half voltage. So it's linear. You could actually customize this. There's a parameter BA7 where you could change it to like a square 1, a square 2, and it'll reduce the voltage on the start, so you're not saturating the motor so much with voltage and leading to high current. We also have the possibility to enable automatic torque boost, so that'll boost up the voltage to give you more torque, more voltage, more current, and theoretically more torque. So V by F is what we run in most of the time. We also have slip compensation, so that's good for like higher starting torque or vertical applications like lifts or hoists and stuff like that. We've used slip compensation in the past. And then lastly, and kind of most unique but not used too often, is the sensorless vector control. So sensorless vector control requires that you program all your motor data. You do a auto tune, which requires you to uncouple the motor from the load. You need to pass the auto tune, and then you could run in sensorless vector. So that's going to give you the most precise control, the most torque per amp, but it's also going to be the most work to set up. So that's why most people just stick to V by F. It's pretty much turnkey. Yeah, so this is actually showing you what I just mentioned, which is the sensorless vector control. So you'd go into DR9, set it to 4, you do your motor data, then you do your auto tune. You could do a non-rotate tune, but what we recommend is actually a rotational tune. And this is going to give you a higher starting torque, It's going to give you a more dynamic speed response and then also tighter speed regulation. So this might be good for a conveyor, for example. So if you're constantly loading and unloading product, you want to keep the amount of torque the same no matter what speed you're running at. This is when a vector control might be for your application. These parameters here are actually from the bottom part of that quick start I just showed you. So a lot of times people want the drive to run no matter what, especially in pumping and HVAC applications. They lose power or they get a trip. They just want to restart that trip. They want to keep running after a power loss. That's what these parameters do here. So you could enable the automatic resets. You could set how many attempts you want to have for resets. And then you could also set up a power on start. So if you ever lose power, as long as the run command's there, the drive will come back on. So from a safety perspective, you just got to make sure that that's allowable. And usually for fans and pumps, it's okay. So that's the applications we most likely enable this on. Kind of also related to fans and pumps is we'll usually enable this, which is our speed search. So a speed search is catching a motor on the fly, also called like a flying start. So if you think you're running a fan and it has some inertia behind it at 60 hertz, then you lose power. It's gradually going to speed down because it's coasting to a stop. But within 2 seconds, if you start up again, the drive may trip out because the drive is going to start at 0 hertz and then it's going to ramp up, but the fan is still spinning 50 hertz, let's say. So enabling this speed search will actually catch the motor with whatever speed it's running on. So it's actually going to ping the motor, a little bit of voltage, read it back, and then calculate how fast it thinks the motor's running, and it's going to start at that speed. So this is parameter CN71, and it's actually broken down into bits. So you could select when you want the speed search to occur. If you turn on all the bits, it's going to do a speed search pretty much at every start. If you select just a certain bit, it will only do it at that time. So it is selectable and adjustable. We could also do frequency limits. This is also like most common for fans and pumps is you could set a low speed limit so you can't run too slow, and you could set a high speed limit to limit your frequency on the top end. And then the last one here is the factory reset. So this is just if you ever want to start from scratch, go back to an out-of-the-box parameter setting. This would be DR93, set it to 1, then the drive gets rid of all the parameters. Okay, so a few more functions I'm going to mention here is just the starting torque. So we mentioned the automatic torque boost. The nice thing about using the auto torque boost is there's no auto tuning required, so that eliminates one of the steps. All you need to do is enable the parameter, and then what it's going to do is it's going to shoot up the amount of voltage that comes out when the drive thinks it needs it, and that theoretically will give you more torque. So if you have like a higher starting torque application, that's when you'd use torque boost. I mentioned the sensorless vector control already, so I don't think we need to mention that again. We actually already mentioned this one too, is the flying start. This just shows how when your output frequency drops off and your motor torque drops off and your power comes back on, how the drive will start back up and actually catch it. So one of the things we mentioned in the first slide was the new UL 61800-5-1. So this is the new UL standard for VFDs that replaces UL 508C. And so you can see on the left and right column here, we kind of compare the differences. So one of the things that needed to be increased is the clearance and creepage requirements. So the distance actually needed to be spaced out a little bit more from like the lower 24 volt supplies to the higher DC bus level power supplies. Additionally, they added or actually doubled the withstand voltage test from like 1500 volt to 3000 volts to 200 volt class, and then 1800 to 3600 volts. So higher test standards pretty much on that realm. Also the short circuit test, we used to have to do a bolted output, so short out UVW and then make sure that the drive detects it. Now it's been expanded to include the DC bus terminals and also the dynamic brake terminals. And then there's a breakdown of component tests. This is like a cotton test essentially, so they put cotton within the drive, run it at temperature and make sure that nothing starts on fire, and then also check the low voltage rise and make sure that, you know, nothing goes out of spec. Additionally, I don't think this was required for the new UL. I think this is just a product improvement on the bottom. We changed the plastic from an ABS plastic to a PPE plastic, which gives you better, flexibility. And if you ever drop the drive, not saying you should, but less likely to crack and fracture on the case. So this is like a little competitive comparison that's showing our mean time to failure. So what we do is we use the military spec handbook to specify and calculate the life expectancy. So we came up with 28 years for a mean time to failure. You can see like Snyder's got 23 years. Yaskawa, they use a mean time between failure, which is slightly different, and they use field data. They predict 28 years, so same as us. And then Danfoss says 45 years, but I don't know any drives that last almost 50 years, so I don't know if I believe it. We also do the humidity and dust resistance specifications. As I mentioned earlier, we do the conformal coating as well, so we conformal coat all the boards. And then we actually have a increase in the humidity, relative humidity rating. It used to be 90%. Now we're good for 95% relative humidity for the environment. All right, so this is showing some of the stuff we mentioned earlier, but more broken up. I mentioned the EMC filter is standard on the 480 volt drives, so that you could leave. It's actually enabled from the factory. You could always disable it if you don't want it. We have the dual ratings, the heavy duty, normal duty, as we mentioned. And then we also have the global certifications, so UL, CUL, CE, all that good stuff. As far as mechanically speaking, the fans are field replaceable. So you just squeeze the little tabs. You could swap out the fans. We do have stock of those. You could always order some spares. We also monitor the fans. So if they're ever running out of spec, the drive's going to trip out on like a fan warning. The field bus options, let's say like Ethernet IP, for example, it's pretty much just snap it right in. You don't even remove the cover. You just pull off this little door, and then you snap in the module. So that's field installed. On that same little door, you could run a remote keypad option. So I think we stock like 1 meter and 3 meter remote keypad options. So if you want to do like a panel mount keypad, that's what that's for. We do have a smart copier, which you could use for copy paste parameters without powering up the drive. So that might be good for any OEM where they're just doing a bunch of the same setups. Some other options we have are the DriveView 9 software. So that's our free computer software for programming all the drives, G100, M100, S100, H100 plus. Right here we have some model number or item codes for cables and keypads and stuff like that. You can also go on our knowledge base, and we should have a list of all that stuff. It's also on the price sheet for those of you guys that have the price sheet. This is showing you the DriveView 9. So we do have another video on our YouTube. It's me talking for an hour about DriveView 9. Most commonly people struggle with the initial connection. So if you have any questions with the connection, I'd recommend giving us a call. And then once you're past that, you'll be able to read parameters, write parameters, backup parameters, do some monitoring and everything. And free to download right off of the website. All right, so I think this might be one of the last slides, which is just kind of, support channels. So we do have our knowledge base. Maybe I'll show you guys that real quick just to make sure you're aware of it. And then we also have the quick start guides, which I showed you. I had a couple of slides that shows the double-sided quick start on programming and wiring and stuff. We do offer free 24/7 support. So I always recommend people call the 800 number. A lot of people like to call me, but that's the problem because I could only answer so many calls. So I recommend the 800 number. We got a few guys that are always willing to help you. You can download the DriveView 9 tool off of our website, and then this is actually the programming cable item number if you wanted to order one of those cables.